Hello everyone. Today I will discuss about the basics of radiation heat transfer. Radiation heat transfer is the heat transfer which is occurring by the means of electromagnetic waves. So radiation heat transfer is the third mechanism of heat transfer. So we get the radiation heat transfer due to the movement of light, because the mechanism of light propagation is the electromagnetic process. So today we will learn how radiation heat transfer occurs and what are the important properties of the radiation heat transfer. And when the light travels, an obstruction is made by some body, then due to the obstruction made in the movement of light, the light wave is converted into the energy, which is called thermal energy. As far as radiation heat transfer is concerned, we know that the very first example is sun. Whatever light is coming out from the sun, this is the example of electromagnetic wave. And due to the movement of this light and obstruction made on this earth, we get the radiation heat transfer. So we have the first example of radiation is the sunlight, which is coming from the sun. So we will study the first example of radiation heat transfer. The very basic example is the sun. Okay. So the sun is constantly radiating light. So we are getting light. So constantly we are getting the light wave from the sun. Okay. The sun is constantly radiating light, and due to the electromagnetic wave, this light is traveling through the space and the medium. And we know that the sunlight which is coming out from the sun, it is having different spectrum. Depending on the wavelength of the light waves, we have different spectrum of light. For example, the gamma rays, the X rays, the visible light, the infrared rays, etc. So whatever electromagnetic waves are coming, they are of different types depending on their wavelength. So we have on this sunlight we have different spectrum. So first we will have gamma rays, we have X rays, we have ultraviolet rays, we have visible light, we have infrared rays, we have infrared rays, we have micro waves, we have radio. Okay. So these are the waves which are coming from the sun. We are getting in terms of different spectrum, because here all these waves are having their different value of wavelength. So depending on the value of wavelength, they are changing their properties. So all these waves are providing different properties due to their different wavelength. Okay. So whatever rays or waves we are getting from the sun, okay, they all are not concerned with the radiation heat transfer. Okay. And here all these waves are not causing the radiation heat transfer. Clear? Only the visible light, infrared rays and some portion of ultraviolet rays are providing heat transfer due to the radiation. We are getting the radiation heat transfer only for particular waves, visible light and the infrared rays, and some portion of ultraviolet rays. So since all these waves are having their different wavelength, so we get this is 1 micrometer or micron. So it is having suppose this part is point 0.1 micron, okay, and suppose their side it is up to 100 micron, okay. So whatever waves we have here, okay, this particular range of waves, they are causing the thermal radiation heat transfer. So we are studying the heat transfer which is caused by the radiation, okay, and that heat transfer due to the radiation is obtained by this particular lights, okay. So the main waves which are the cause for the radiation heat transfer are visible light and infrared rays, and some portion of the UV light are also providing the heat transfer, and this heat transfer is called thermal radiation. The topic of today's class, the radiation heat transfer. Here this radiation heat transfer is nothing but the thermal radiation, and this thermal radiation is caused by the two waves, mainly two waves, visible light and the infrared, clear, and which are having their particular wavelength. The electromagnetic waves which are having wavelength of 0.01 to 100 micron, they are providing the thermal radiation, okay. So this is the very key point of this class, where we understand the thermal radiation is caused by the waves which are having the wavelength in the range of 0.01 micron to the 100 micron, clear, and all other waves are not providing radiation heat transfer, okay. So we can simply understand that thermal radiation is not obtained due to the movement of these gamma rays, X rays, UV rays, microwaves and radio waves, okay. I hope that you have understood the radiation heat transfer which is known as thermal radiation. These gamma rays, X rays, you know that they are having the wavelengths which are very less, very less than 1 micron, okay. And so after the infrared, whatever range we have of microwave and radio waves, they are having the larger wavelength. So if you move further downward, we have the wavelength which is very much bigger than 1 micron. We have started the class with the the basic definition of the radiation heat transfer, and subsequently we have learned the the very basic example of the radiation heat transfer, where we have understood that sun, okay, how different types of waves are coming out from the sun, okay, and what are the reason for creating the thermal radiation heat transfer. So to proceed ahead, we must learn some important points about the radiation heat transfer, okay. Some other important points about the thermal radiation are no medium. We know that in case of conduction heat transfer and convection heat transfer, we need some kind of medium, okay. Conduction heat transfer and convection heat transfer will not occur if there is no medium, okay. But in case of radiation, very interesting point is that no medium is required. So the one important topic about the radiation heat transfer is that no medium is required for radiation heat transfer, okay. And second point is vacuum. vacuum. Okay, the second point is vacuum. So in vacuum the radiation is highest. Radiation is the highest or most, and in vacuum the radiation will most effectively occur. Radiation heat transfer will cause only when obstruction is made. Obstruction is made in the movement of light waves. Okay, so when light propagates, if there is no obstruction, there will be electromagnetic waves, but there will be no thermal radiation. Only when in the movement of the light obstruction is made, so only when the light is moving, okay, light is having the propagation and obstruction is made, only that case the heat transfer will take place. Thermal radiation will take place only when an obstruction is made in the path of the light waves. So this is very basic point about the thermal radiation. Fourth point, we have the thermal radiation will be maximum at the highest temperature. The radiation heat transfer will be maximum at the maximum absolute temperature. Thermal radiation is very high at larger absolute temperature body. Okay, so if the absolute temperature of the body is very large, then the radiation heat transfer will be very big. We learned that the very basic example of radiation heat transfer was the sun. So the very basic example of the radiation heat transfer is the heat transfer we are getting from the sunlight, which is coming from the sun. Okay, so in addition to this sun, we know that everybody, okay, all the materials on the earth are radiating heat transfer, and some other very major examples of radiation are filament, light filament. We have a second example, light filament. We have furnaces. We have nuclear explosion. We can say combustion chamber. So whatever examples I am providing here are the major examples to provide the radiation heat transfer. So now we will learn about some properties which are relevant to radiation heat transfer, and those properties are reflectivity, absorptivity and transmissivity. Okay, so let us learn about these three properties: reflectivity, absorptivity and transmissivity. Okay, so these are the important properties in connection with the radiation heat transfer. Okay, so to understand these properties, we must draw a figure. By drawing the figure, we can understand how these properties are obtained. Okay, so to understand these properties, we have simply one surface. Okay, one surface we have one material surface okay. So if radiation takes place, so this is the incident radiation, this is incident radiation. So the incident radiation is impinging on the surface of this body, okay, and when this incident radiation will take place on the surface of this body, okay, and this incident radiation will be divided into other three parts of radiation. So it is here G, we denote this incident radiation by G, and whatever G will come on this surface, a part of radiation will be reflected, okay. So this is reflected radiation, which is denoted by GR, okay, and another portion will be absorbed by the body, okay. So whatever incident radiation will impinge on the surface, a part of rays will be reflected, which is reflected radiation denoted by GR, and another portion of this incident radiation will be absorbed by this body, okay. So it will be, we write here, absorbed radiation, which can be denoted by GA, okay. So there will be third portion of this incident radiation which will be transmitting through this body. So this is called transmitted radiation denoted by GT. So we obtain that when on any surface the incident radiation will impinge, this will be divided into three parts of radiation. One is called the reflected radiation GR, another will be absorbed radiation GA, and the third part will be transmitted radiation GT. So this is about the incident radiation which will occur on any surface. Clear? After getting into the surface of any body, this radiation will be converted into three parts, okay, reflected one, absorbed one, and transmitted one. Now we will apply the energy conservation principle in this case, okay. So by applying the conservation of energy, we have GA plus GR plus GT equals to G. That means whatever incident radiation, which is also called as irradiation, G, will be divided into three parts of this radiation, and this energy, radiation energy, is equal to the sum of all these three radiation. So finally we have got GA plus GR plus GT equals to G as per the conservation of energy. So now we will divide dGA by G, all term by G, we have G divided by G, okay. So we are getting alpha plus rho plus tau equals to 1. So this is the very basic equation we obtain by applying the conservation of energy. So here this alpha means this GA by G, and rho means GR by G, and GT by G means tau, okay. And here this property is called absorptivity. absorptivity, and this is called reflectivity, and tau is transmissivity. Okay, so in this case, in this way we get three properties, okay, absorptivity, reflectivity and transmissivity. So from this equation we can understand this absorptivity is the a property of this material which is representing the capacity to absorb the radiation. Okay, and similarly we have the property reflectivity of this particular body which is representing the capacity of this body to reflect the radiation. Okay, and the third property we have here, transmissivity. This is a property of this material which is representing the capacity of transmission. So whatever capacity this body has to transmit the radiation through its body, it is called a transmissivity. Okay, so in this way we get the three properties, reflectivity, absorptivity and transmissivity of this particular body in connection with the radiation heat transfer or thermal radiation. And depending on these three properties, absorptivity, reflectivity and transmissivity, we can divide different materials, different body which are subjected to the radiation heat transfer. Okay, so we can classify the materials which are radiating heat transfer. So moving ahead to define different body or different materials, we have black body. Okay, so this black body will be the body or surface which is absorbing all the incident radiation. Okay, so when absorptivity will be 1, okay, then this body will be called black body. If we have this body as a black body, then we can understand this black body will absorb all the incident radiation. Okay, so black body is defined when alpha equals to 1, when all other reflected radiation and transmitted radiation will be 0. So whatever incident radiation will occur on this surface, all part of incident radiation will be absorbed by this particular body. Only then that body will be called black body. So black body will be the body when alpha equals to 1. That means rho equals to 0 and tau equals to 0. Okay, so this is one important body which is existing in case of radiation heat transfer. The second body we have opaque body. Okay, so second body is opaque body when there will be no transmissivity. Okay, when there will be no transmissivity, then body will be called the opaque body. That means when transmissivity will be 0, then this body will be called opaque body. Okay, in other way, if this body is a opaque body, then this body will not transmit a part of this incident radiation. Okay, so here we have this rho plus alpha n equals to 1. So here in case of this opaque body we have 0 transmission, but we have the reflection as well as the absorption. So in the third case we have white body. Okay, so white body will be the body which will reflect all the radiation. Clear? So white body is a body when all the incident radiation will be reflected. Clear? That means its rho will be 1. When rho will be 1, when reflectivity will be 1, then it is called white body. Okay, so in case of white body, there will be no transmitted radiation, there will be not absorbed radiation. So whatever incident radiation it will fall on the surface, all parts of incident radiation will be reflected. In that case, it will be called white body. Okay, and the final body we have is gray body. Gray body. Okay, and gray body will be different from all these bodies because this body will provide all these properties in uniform value. Okay, so when all these properties are uniform, absorptivity, transmissibility and reflectivity, then this body will be called gray. Okay, so when alpha plus rho plus tau equals to 1, we have the gray body. So, and when absorptivity, reflectivity and transmissibility will be uniform, which will equal to 1, then it is called gray body. Okay, so in case of gray body, we will have a surface when incident radiation will be converted equally into reflected radiation, transmitted radiation and absorbed radiation. So these are important bodies which are relevant to this radiation heat transfer. So that's all for today. I hope that you have learned important points about the radiation. I hope that you have found all these points are very interesting. Thank you so much.